Okay, calculus, we are going to attempt to teach you optimization problems. They're word problems. Your fave. All right, here we go. Late night videos, late night calculus videos. And by the way, thanks for never coming to my Google office hour meet. You should come visit me. Kind of lonely. All right, here we go. Again, these are word problems. So the first step is to make a sketch. All right, everybody can make a sketch. There's your first point. So example number 1. We want to find the dimensions, so let's underline that. That's what it's asking us for. So find the dimensions of a rectangle with a perimeter of 100 meters whose area is as large as possible. So obviously we're dealing with the rectangle, so everybody can draw a rectangle. There you go, everyone can get a point. All right, number 2, up here, assign the needed variables. Okay, well, if we're dealing with perimeter and area, we need, and the dimensions, of course, we need the length and the width. So I'm just going to use good old X and Y. All right, it doesn't matter what variables you use. You pick. Go crazy. All right, so that's the first 2 steps. Draw the sketch, assign variables. Now, you're going to be writing 2 equations. All right? Let me just label this here. This is kind of the first and second steps. All right, the variables. Okay, now you're going to be writing 2 equations. All right, so step 3, we're going to write the constraint equation. All right, so I'm going to highlight that. Constraint. All right, the constraint equation is what is restricting you. All right, so it is what is restricting you, and it is found in the given information. All right, so let's look at our given information. All right, this is the given information right here. So this is the given info. So that is going to be information. All right, so that's going to be our constraint. All right, so that's kind of our third step. We're going to write a constraint equation. Our constraint function, and I'm going to have you write this out when we get to the test. Our constraint function is perimeter. All right. And the equation for the perimeter of a rectangle is you add up the sides. Y plus X plus Y plus X. So our perimeter is equal to 2X plus 2Y. But now we know what the perimeter is. That's given to us right here. So we can plug that in right away. 100 is equal to 2X plus 2Y. So there is your constraint equation, and you are going to make sure that you label that. That is our constraint. Alrighty? Okay, so that was the third step. Now the fourth step, we're going to write an equation for the objective function. So I'm going to highlight that in blue, alright? The objective function. The objective function is what you are trying to maximize or minimize. So you look for the key words. In this case, I'm going to underline it in blue right here. Area is as large as possible. All right, another thing, maximum area. That's what you're maximizing and minimizing. So that is your objective. All right, so now we're going to write that equation. That's kind of our fourth step. All right, and again, I'm going to have you write it out. What is your objective function? All right, the function is area. All right, and the formula for the area of a rectangle is good old base times height. So in our case, it would just be X times Y. So A is equal to X times Y. And we're going to put a box around that. That is our objective. All right, objective equation. All right, so those are your first kind of 4 steps. So to recap, draw the picture, assign variables, and you're going to write 2 equations. You need a constraint function. That is always your given information. It's what's restricting you. Obviously, if we only have 100 meters for the perimeter, we can't have the biggest area in the whole world. And then your objective function and equation, that's what you're trying to maximize or minimize. All right, so now here comes the fun. Step 5. All right, here's what we're going to do. You're going to solve the constraint equation for 1 variable. All right, so I'm going to go off. I'm going to go right over here. Oh, so I'm going to go down here. All right, so I'm going to take my constraint. So we're going to solve the constraint for one of the variables. Now, you always want to pick the easiest algebraically. All right, that's key. You want to make the easiest thing you can do. So in this case, I'm going to just write my equation here. 100 is equal to 2x plus 2y. In this case, it doesn't matter. Solving for x or solving for y, one isn't any easier than the other. So you just pick. All right, I'm going to solve for y. I'm just going to write that down. Solve for y. All right, so the first thing that we're going to do to get y by itself is we have to subtract off 2x. All right, so we have let's see, negative 2x plus 100. I'm going to put the x term first, is equal to 2y. And now I simply have to divide both sides by 2. All right. In fact, I'm even going to break this down more so we don't make this mistake. Every single part has to be divided by 2. All right. Everything gets divided by 2. So this is going to give me negative x. This is going to give me 50. And then my 2's cancel out. So negative x plus 50 is equal to y. All right. Now we are going to highlight that, because that one you want to keep track of, and I want you to label that. All right, that is my solved constraint. All right, so once you write your constraint equation and your objective equation, then you take that constraint equation and you solve it for a variable. I solved it for y. Now you're going to, so that's kind of the first part about step 5. That's kind of 5A, I think we called it up here. Let's go check. Yes, 5A. Solve the constraint equation for one variable. Choose the easiest algebraically. Now the second part is you're going to take that solved constraint equation and you're going to plug it into the objective equation. All right? So the second part of step 5. All right? Plug the solved constraint equation into your objective. Okay, so my objective equation, I'm just going to write it out. A is equal to x times y. But instead of y, I'm going to plug in my solved constraint. All right, I'm going to take this and plug it in right here. All right, so a is equal to x, but my solved constraint tells us that y is equal to negative x plus 50. Negative x plus 50. So do you see what we did there? We have one variable, and that's why we did all this. We need one equation with one variable. All right, so we're going to simplify that. We're going to distribute here. So our area is equal to negative x squared plus, if we distribute there, we get plus 50x. Okay, now this, we're going to give this a name. This is our new objective. Lots to keep track of here. Good thing you get to use notes, right? That's our new objective. And as usual, the more times you go through these steps, you're going to get it. All right, so let's recap. All right, so you need a constraint function, an equation. That's the given information. It's what's restricting you. You're always going to have a given. You need an objective function and an equation. That's what you're trying to maximize or minimize. You take your constraint equation and you solve it for one variable, and you plug it into the objective and simplify, and that is your new objective. All right, so now we're finally ready to do some calculus, and that's kind of our 6th step. So let's go back up here. We are going to optimize. That just means we want to figure out where the max or min is going to be. So this is where we, in order to find a max or min, just like we did in our previous assignment this week, is we are going to do the first derivative test. All right, so step 6, here we go. All right, we need to take the derivative. We need to take the derivative of the new objective. All right, because we need to find a max or a min, so that's our first derivative test. So I'm going to call it A prime, and this is just power rules. The derivative of negative x squared, of course, is just negative 2x. And the derivative of 50x is plus 50. All right? And then, of course, now we need the first derivative test. All right, so if you remember, that's where we set our derivative equal to 0 and solve for x. So a little bit of algebra here. I'm going to subtract 50 from both sides. So negative 2x is equal to negative 50. And then I'm going to divide by negative 2. So my x is equal to, it looks like, positive 25. All right, so there is my x-intercept. Now remember, wherever there's an x-intercept on your derivative, that's where a max or min will be on your original function. So now we have to figure out if this is what we need. So now we set up our number line. All right, we put our x-intercept on our number line. We label the bottom row the derivative, and we label the top row the original function. This is the first derivative test, so that is what you're putting in y equal. So you want to graph the derivative in y equals. You want to start your table at 25 and look to the left and to the right of it. All right, so I'm graphing this, negative 2x plus 50. I'm starting my table at 25, and I'm looking to the left of 25. I'm seeing positive y values here. All right, to the left, and I'm seeing negative y values here. So that tells me that in this interval, if my derivative is positive, my function is increasing there. All right, and then if my derivative is negative over this interval, that means my function is decreasing here. So we have just proved that 25 is indeed a maximum. And that's what we need, because if you go back up to what the question is asking us for, right up here, whoa, lots of work. All right, we're looking for a maximum area. So thankfully, we have what we need. So now we're ready to solve the problem. All right, so we're going to solve the problem. This problem asked us for the dimensions. All right, so we already have x is equal to 25. Now we have to find y. All right, to find y, we already have an equation that's solved for y. We are going to use our solved constraint. All right, so let's go back up and get a solved constraint, and that's why we label things as we go. Hey, right here, isn't this already solved for y? I can plug in my x right here and find y. All right, so let's do that. So my solved constraint is y is equal to, negative x plus 50. So I plug this x right in here. Y is equal to negative 25 plus 50. So my y is equal to 25. So those are my answers. All right, my dimensions are x is equal to 25 and y is equal to 25. Now, did the question ask us for anything else? Let's go back and read. All right, what is the maximum area? So now we have to find the maximum area, and we know that our objective equation was the area, x times y. 25 times 25 gives us 625 units squared. And in fact, the problem did give us specific units, meters. Okay, so that's optimization. Some of you, if you remember from geometry, remember the biggest area will always be a square. But we just did all that work to figure that out. So that is a pretty simple optimization problem, just to help you get used to the steps. All right, so we're going to do another example on the back side, but let's just recap. All right, so here we go. You need a constraint. That's where the given information is. You need an objective equation. That's what you're trying to maximize or minimize. You solve the constraint for one variable and plug it into the objective. Your goal is to have one equation with one variable. All right? Once you plug it in and simplify, then it's time for calculus. You take the derivative, set it equal to 0, set up your number line for the first derivative test, and then solve the problem. All right, see you on the back side. Okay, we're going back to work here. Here we want to find the dimensions of a rectangle with an area of 1,000 whose perimeter is as small as possible. Okay, so the first step, obviously we just draw the picture. Easy peasy. The second step, we assign the variables. We're dealing with perimeter and area of a rectangle, so we need a length and a width, base times height, whatever you want. I'm just going to use x and y. So those are my first two steps. The third step is my constraint. All right, so the constraint is found in the given information. So I'm going to go up and I'm going to highlight that in red. The area of 1,000, that's our given information. So in this case, our constraint is going to be the area. All right, so the function is area, and you have to list the function, and the equation is just x times y, but we know that the area is equal to 1,000, so we plug that in. 1,000 is equal to x times y. So there's our constraint. All right, the fourth step is we need the objective. What are we trying to maximize or minimize? All right, so I'm going to highlight that. We are trying to find a perimeter that is as small as possible. All right, so this is our objective. So it's kind of switched from the front side. All right, so our perimeter of a rectangle is just 2x plus 2y. So there's my objective equation. Okay, now we go to the fifth step. The fifth step tells us that we solve the constraint. All right, for one variable, and always pick the easiest. In this example, our constraint equation, one isn't any easier than the other, so we take our constraint, 1,000 is equal to x times y, and I'm going to solve this for y. So I'm just going to divide both sides by x. So y is equal to, these cancel, 1,000 over x. Now again, this is the one that you really want to keep track of. Put a box around it and label it. That is my solved, oops, not highlighter mode. I haven't done that for a while. That is my solved constraint. All right, and again, make sure you keep organized because that's the one you're always going to come back to. All right, so that's kind of the first step of part 5. Now the second step, plug the solved constraint into your objective. All right, so I like to just bring my objective down right here. Perimeter is equal to 2x plus 2y. But instead of y, I put in what y is equal to. I take this and plug it in right here. All right, so 1,000 over x. Again, your goal is to have one equation with one variable. So I've got it down to just x's. Now I need to simplify this because your goal is to be able to take the derivative of this easily. Right now, because there's a fraction there, that's not so easy to take the derivative of. So we're going to simplify. All right, so perimeter, sneak it in there for you, simplify. So perimeter is equal to 2x. Now I'm going to put 2 over 1, and I'm going to multiply these two fractions, tops and bottoms. So that gives me plus 2,000 over x. All right, now again, this still has a fraction, and I want to be able to take the derivative of this. So I'm going to rewrite this. I'm going to take my x to the first right here, and I'm going to move it up here. So perimeter is equal to 2x plus 2,000 x to the negative 1. And that right there is my new objective. So I like to kind of highlight that one. And of course, label it. That is my new objective. Okay? So again, let's go recap, and hopefully you're starting to get the pattern. You need a constraint equation. You need an objective equation. You always solve the constraint for the easier variable, and then you plug it in to the objective and you simplify it to the point that it's easy to take the derivative of. This is all power rules here. Okay, so let's keep going. Step 6 is to take the derivative and the first derivative test. All right, so then we need the first derivative and the first derivative test. So we call it P prime. All right, power rules. The derivative of 2x is 2. All right, if we use the power rule here, negative 1 times 2,000 is negative 2,000, and then x to the negative 2. Okay, now, our goal is to set this thing equal to 0. So 0 is equal to 2 minus 2,000 x to the negative 2. We have to set this equal to 0 and solve for x. But I cannot solve for x with a negative exponent. So I need to rewrite this. All right? Because we need positive exponents. All right? So here we go. 0 is equal to 2 minus 2,000 over x to the positive 2. Okay, now I'm going to make this a fraction. The easiest way I can tell you to solve this for x is to move this over here. Subtract 2 from both sides. So we get negative 2 over 1 is equal to negative 2,000 over x squared. Again, the easiest way to do this is to move this over here. Now I have two fractions with an equal sign in the middle, and now we're back to easy, easy, easy. We can cross multiply. All right, everyone loves to cross multiply, right? Okay, so let's go this way. That gives us negative 2x squared. And then if we go this way, across here, we get negative 2,000. Oops, well, I can do two different colors. That won't mess you up, will it? Late night, remember? Okay, so now this is easy to solve for x, guys. We just divide by negative 2. So we get x squared is equal to 1,000. We square root both sides. X is equal to positive and negative, and I'm getting a decimal, 31.6. Now, we do not have to worry about the negative because you obviously can't have a negative side link, so you don't need to worry about it. Okay, so there is our x-intercept on our derivative. All right, a lot of algebra in this example. So now we can set up our first derivative test. Alrighty, so remember, we put in a number line. We put that x-intercept of our derivative on the number line, and we label our number line. The bottom row is the derivative. We're using the derivative to tell us about the original function. This is the first derivative test, so that's what we have in our calculator. Okay, so I'm graphing my first derivative. Let's go back up and make sure you're putting the right one in. This right here is the easiest one. Right here. This is the easiest one to graph. All right, so put this in y equals and start your table at 31.6. Okay, when I do that, I am seeing negative y values over here, and I am seeing positive y values over here. So that's looking good because we need a minimum. We are decreasing here because our derivative is negative. We are increasing here. So we have just proved that this is a minimum. And that's what we need. You have to prove using the first derivative test that your x-intercept, your critical point, is what you need, a max or a min. Okay, so remember that's our x. So now we're ready to answer the question. All right, so my x is equal to 31.6. Now we have to find y. And remember, you always go back to the solved constraint. Okay? So our solved constraint, remember, was y is equal to 1,000 over x. So now we have y is equal to 1,000 over my x, which is 31.6. So again, my y value is also, if I divide that out, my y value is also 31.6. All right, so there is my x and there is my y. I've answered my question. It asked me for the dimensions. All right, let's go back up here and make sure we answered all the questions. Find the dimensions of the rectangle with an area of 1. Okay, so we did answer the question. This one doesn't actually ask us for the perimeter, so we don't have to find it. We are done. And that is optimization problems. A lot of algebra, kind of some geometry. Lots of fun. Okay, your goal for today's assignment is just to get through these notes, and then we will practice it tomorrow. Take care, Calc. Come visit on Google Meets, please. Miss you. Love you. Toodaloo.